Greetings everyone, this is Non-Expert here, back again with another video. Today we are going to be solving problem number 47, and the difficulty it's been rated that is easy. This problem was asked by Facebook. I've seen it being asked on Amazon and Goldman Sachs as well. Cool, so let's get down to the problem description. So given an array of numbers representing the stock prices of a company in order, write a function that calculates the maximum profit you could have made from buying and selling that stock once. So you must buy it before you can sell a stock, and you've been given an example over here where you have the quoted price of the company, and as you can see over here, the best portion on which you can buy a particular stock and sell it, the maximum profit you can gain is by actually buying the stock when it's at 5 and then selling it off when it's at 10, and therefore you will accumulate the difference of 5, and that's what you want. So basically you want to find out the maximum profit that you can make, and fortunately we were able to find a similar problem on LeetCode, and the name of the problem is the best time to buy and sell stock. Again, I would sort of urge you to pause this video and check out the link given in the description below and try solving this problem on your own, because this is a pretty simple problem, to be very honest with you. And there are basically two ways of solving this problem. You could use a brute force approach in which you run two loops, one loop and then another loop just to check out the maximum difference, and that will work of n square. But you could actually sort of use it or sort of improve that and do this in one pass itself. And the ways to sort of go about it is you want to find the minimum value, and then whatever the maximum value is after the minimum value, that's what you want. So if you look at 7, 1, 5, 3, 6, 4, as you can see over here, you could actually buy stock at 1 and then sell it off at 6. So basically what you will be doing, you'll be storing a value in your minimum, and then you'll be storing a value in your maximum, and then you'll be moving forward from there. Again, you could sort of look at it as peaks, and we need to find the largest peak following the smallest value before it. Again, we just have to maintain two variables over here, the min price and the max profit, and each of them are correspond to the same values that we've just represented. Cool. So again, if you didn't understand what I was saying, it's easier to write code on it. So let's just do that. And again, the way we start is by basically writing our base condition. So we just write, hey, if prices have not been given, we just return nothing. And do note over here we need to return an integer, so we'll return 0. And now we come to our main solution. So there are two ways of going about it is, and the first way is by actually setting a value, and let's just call it a min price value. And what we can do is we can actually give it a very high value. Let's just give it the maximum value that it can be given. And for max profit, we'll just make it as 0. And this max profit is what we'll be using at the end. So this is what we're going to be returning. And now all we have to do is we need to do an iteration. And while we do the iteration, we need to understand where the price that we add for that particular stock, whether it's very high, and go on from there. So let's just do that. We'll just say for price in prices. All we need to understand over here is that if your min price is actually greater than the price, then you sort of update the min price and then you move forward from there. So let's just do that. You just say, hey, min price, and actually we can sort of do this in one shot. We'll just say whatever's the minimum between the min price and the price that we're presently on, that's the min price that we have, right? And now all we have to do is we just have to try to understand whether we can match it with our max price. One other thing which people don't try to understand is the fact that you would want to sort of do this in an if-else condition sort of a way, and we'll do that just because it sort of helps us break our solution down into multiple portions. So let's just do that. We'll just say, and we'll just remove this. We'll just say, hey, if price is less than min price, at that particular moment of time, you need to update your min price, right? So min price is equal to price, and otherwise all we have to do is we just need to understand the min price that we've computed so far. When we subtract it with the price which is presently at, if that value is greater than the max value, then we update the max value as well. So again, all we have to do is we just say, hey, if price minus min price is actually greater than the max profit that has been accumulated, then max profit needs to get updated. So let's just do that, and that's basically it. And yeah, we'll just write a few print statements so that you get a better understanding of what all is happening. So you have your price, you have your min price, oops, and you have your max profit. Cool. And again, there's nothing more here to do. You're just maintaining a min price and you're maintaining a max profit. And the only thing that you're making sure of is that the min price that you have, you only compute the max profit after you compute the min price. So let's just run our code. Hopefully it should run and it should give us a better understanding of how it's working. So you can see that the output is the same as the expected output. But what's more important is as you're traversing through each of those elements, you're updating them as you move forward. So you have 7 first. So this is your min price, and these were just the values that we had initialized first. And now all you're doing is you're just updating min price with 7. And your max price or your max profit rather still remains 0 because it's not been computed yet. But what's going to happen in this scenario is that 1, which is the price that we're presently on, is actually going to be less than the value, the min price that we're presently on. So that thing's going to get updated, and then this 1 value is going to be used forever because there's no value less than that, and we're just going to keep on computing from there on forward any other value which has a max profit which has been greater than the one which has been calculated. So over here you have 5, and what you do is you just subtract 5 minus 1, that's 4. So basically all you're suggesting over here is, as you can see in this thing which I've highlighted, if you buy on the second day at the price 1 and you sell at the third day at the price of 5, a profit of 4. If you do the same for the third day, you get a profit of obviously 2, which is less. So that's how you sort of maintain this entire relation. But then when you go on 6, you see that the max profit which had been accumulated before, which was 4, was actually less, and that's the way we want to go about it. And that's basically it. This is actually a pretty simple problem. There's not much here to it. Let's just run this code one more time. Cool, and let's just submit this. Awesome, so you can see that the solution is faster than 93% of the Python online submissions, and the very reason for this is just because we're doing this in a complexity of O of n. Again, if you had any comments or if there's something that you do not understand, do leave it in the comment section below, and I would love to handle any of your queries. And if you did like this video, do give a like and do subscribe to this channel. We are discussion over here, and we would love to have you on board with us. Again, if you've already subscribed, you're awesome, we all know it, and have an awesome day. Thank you.